The human mind is fundamentally ill-equipped to comprehend the true nature of absolute nothingness. When we look up at the night sky from a place untouched by the artificial glow of modern civilization, we do not see a void. We see an intricate tapestry of light, a dense, shimmering field of celestial bodies that has captivated our species since the dawn of consciousness. For millennia, these distant beacons were viewed with a sense of profound wonder, mystical reverence, or romantic hope. They were symbols of the infinite, promises of future horizons, or the homes of gods who watched over our small, fragile world. But as the tools of modern astrophysics replaced the myths of antiquity, that comforting tapestry began to unravel. The stars did not change, but our understanding of the space between them did. We came to realize that the light reaching our eyes was not a welcoming signpost, but a message from an ancient, silent graveyard. To understand the true horror of our cosmic situation, we must first confront the sheer, staggering architecture of the universe we inhabit. Our home galaxy, the Milky Way, is a barred spiral structure spanning roughly 100,000 light-years from edge to edge. Within this single galactic disk, there are an estimated 100 billion to 400 billion distinct stars. Each of these stars is a massive nuclear furnace, fusing hydrogen into helium, radiating immense energy across the electromagnetic spectrum and anchoring its own collection of orbiting bodies. For a long time, humanity could only guess whether other stars possessed worlds similar to our own. The planets of our solar system were seen as anomalies, unique configurations of matter in a largely barren universe. That assumption was shattered in the late 20th and early 21st centuries with the advent of dedicated spaceborne observatories, most notably the Kepler Space Telescope and its successor, TESS. These instruments utilized the transit method, monitoring the incredibly minute dips in a star's brightness as an orbiting planet passes in front of it, to pull back the veil on the galactic population. What they discovered was a cosmological revelation. Planets are not rare anomalies, they are the standard. Statistically, almost every single star you see in the night sky anchors at least one world. The mathematical progression from this discovery is as relentless as it is terrifying. If we take the most conservative estimates provided by modern astrobiology, roughly 20% of all stars in our galaxy are sun-like, classified as yellow dwarf stars of the G-type spectrum, or stable K-type orange dwarfs. Of these stable, long-lived stars, approximately 1/5 are believed to harbor a planet within their circumstellar habitable zone, the orbital region where the thermal radiation from the host star allows for the existence of liquid water on a solid planetary surface. This is the Goldilocks zone, the foundational cradle where life as we know it can theoretically emerge. When you apply these conservative fractions to a galaxy containing 400 billion stars, the resulting figures defy human intuition. The equations dictate that there should be between 8 billion and 40 billion Earth-sized, potentially habitable worlds within the Milky Way alone. This is not the total number of planets. This is merely the number of planets that share our specific, life-supporting parameters. Worlds with the right mass, the right chemical composition, the right distance from their stellar engines, and the right atmospheric potential to foster the delicate chemistry of life. Yet, the true anomaly of our cosmic position does not lie in the spatial dimensions of the galaxy, but in its temporal depth. The universe is ancient, its birth hard-coded into the cosmic microwave background radiation at approximately 13.8 billion years ago. The Milky Way formed shortly thereafter, stabilizing into a mature, star-forming system roughly 11 billion years ago. Our own solar system, by comparison, is a relative newcomer to the galactic stage. The interstellar cloud of gas and dust that collapsed to form the Sun, the Earth, and the sister planets did so only 4.6 billion years ago. This means that for nearly 7 billion years before the first organic molecule ever formed on Earth, the Milky Way was already an ancient, fully operational engine of star and planet formation. billions of Earth-like worlds cooled, stabilized, and orbited their respective suns eons before our planet was even a gathering mass of molten rock. If life is a natural consequence of planetary chemistry, if the transition from non-living matter to organic, self-replicating structures is an inevitable event given the right ingredients and enough time, then the implications of this 7-billion-year cosmic head start are profoundly disturbing. Consider the baseline of human technological development. It took our species roughly 200,000 years to transition from primitive stone tools to the Industrial Revolution. From the Industrial Revolution to the split of the atom and the creation of the digital microchip, it took less than 2 centuries. From our first primitive, canvas-winged atmospheric flight at Kitty Hawk to the landing of the Apollo 11 lunar module on the surface of another celestial body, a mere 66 years elapsed. If a technological civilization can transition from terrestrial confinement to interplanetary exploration in less than a single human lifetime, what does a civilization look like when it has been developing for 10,000 years? What does it achieve after 100,000 years? What happens when a civilization possesses a head start of 1 million, 100 million, or 1 billion years? In the mid-20th century, a brilliant Italian physicist named Enrico Fermi sat at lunch with his colleagues at the Los Alamos National Laboratory. The conversation had turned to recent reports of flying saucers and the statistical likelihood of intelligent extraterrestrial life. Fermi, known for his uncanny ability to calculate complex physical problems in his head using rough, back-of-the-envelope estimations, fell silent as his peers debated the nature of alien technologies. Suddenly, in the middle of a completely different topic, Fermi turned to his colleagues and asked a deceptively simple question that would echo through the decades of modern science. Where is everybody? This is the foundational core of the Fermi paradox. It is the violent, irreconcilable clash between two deeply rational, empirically grounded scientific conclusions. On one hand, we have the Copernican principle, or the principle of mediocrity, which states that there is nothing inherently special, unique, or privileged about the Earth, our Sun, or our position in the space-time continuum. We are a common planet, orbiting a common star, in a common spiral arm of a common galaxy. Therefore, the intelligence that emerged here should be a common phenomenon throughout the cosmos. On the other hand, we have the observational reality. When we point our most advanced optical, radio, and infrared telescopes into the deep void, we find absolutely nothing. No artificial radio signals, no massive engineering structures blocking the light of distant stars, no self-replicating robotic fleets traversing the interstellar medium. The universe responds to our presence with a suffocating, absolute silence. This contradiction cannot be dismissed as a minor scientific curiosity. It is an existential crisis of the highest order. The absence of any discernible sign of intelligent life in a galaxy that should be teeming with it implies that something is fundamentally wrong with our understanding of reality. It suggests that a hidden factor, a cosmic law, a lethal evolutionary barrier, or an active, malevolent force is systematically erasing civilizations before they can make their presence known to the wider universe. The silence is not neutral, it is an active phenomenon. It is a physical property of our galaxy that requires an explanation. To appreciate why Fermi's question is so devastating, one must examine how an advanced civilization would naturally interact with the physical medium of the galaxy. In 1964, Soviet astronomer Nikolai Kardashev proposed a scale to categorize technological civilizations based on the total amount of energy they were capable of utilizing. A Type 1 civilization is one that can harness and store all the energy available on its home planet, including the entire solar budget reaching its atmosphere, the kinetic energy of its oceans, and the thermal power of its crust. Humanity is not yet a Type 1 civilization. We currently sit at roughly 0.73 on this scale, relying heavily on the chemical energy of fossilized organic matter. A Type 2 civilization represents a monumental leap in evolutionary scale. Such a species has outgrown the energy confines of its homeworld and has developed the technology to capture the entire energy output of its host star. The most famous theoretical model for achieving this is the Dyson sphere, a colossal swarm of orbital collectors, mirrors, and habitats constructed from the disassembled material of uninhibited planets, completely enclosing the star to intercept its light. A Type 2 civilization would command an energy budget roughly 10 orders of magnitude greater than everything currently consumed by the entirety of human civilization. A Type 3 civilization represents the ultimate expression of material mastery within a single galaxy. This is a species that has expanded across the interstellar void, colonizing thousands or millions of star systems and connecting them into a single galaxy-spanning energy network. A Type 3 civilization would be capable of utilizing the energy of hundreds of billions of stars simultaneously, manipulating the structure of galactic arms and controlling the trajectory of entire stellar clusters. When Kardashev proposed this scale, he assumed that as a civilization's energy needs grew exponentially, its physical visibility would grow with it. A Dyson sphere enclosing a star would block its visible light, but it could not violate the laws of thermodynamics. The energy captured by the orbital collectors would eventually be re-radiated into space as waste heat, causing the star system to glow intensely in the mid-infrared spectrum. A galaxy occupied by a Type 3 civilization would look profoundly unnatural. It would be dotted with thousands of infrared anomalies, stars blinking out of the visible spectrum, and unusual structural patterns in the distribution of stellar dust. Yet, when modern infrared surveys, such as the Wide Field Infrared Survey Explorer, WISE, examined hundreds of thousands of nearby galaxies and millions of individual stars within the Milky Way, they found no evidence of Type 3 engineering. The infrared signatures of the cosmos match the cold, predictable outputs of natural, inanimate astrophysics. There are no signs of grand engineering, no galactic networks, no cosmic monuments to intelligent design. The universe appears to be completely unmanaged, wild, and utterly dead. The terrifying implication of this observation is often masked by our cultural narratives of science fiction. We are accustomed to stories where space travel is inherently difficult, dangerous, and slow, where generations must pass in the dark before a starship can reach the nearest stellar neighbor. These narratives give us a false sense of security, allowing us to believe that the alien empires are out there, but they are simply too far away, or their ships are too primitive to bridge the immense gulfs of the interstellar medium. But this is an illusion born of our limited temporal perspective. When we analyze the physics of interstellar colonization with cold mathematical rigor, we find that the colonization of the entire Milky Way is not a project that requires billions of years or impossible, faster-than-light technologies. It is an objective that can be accomplished using known, conventional physics in an incredibly short period of time relative to the age of the galaxy. Imagine a civilization that has achieved a stable Type 1 status and has begun to transition into a Type 2 species. They construct a single, highly automated colonization vessel. This ship does not need to travel at the speed of light. It does not require warp drives or wormholes. It travels at a conservative, sub-relativistic speed of roughly 1% of the velocity of light, approximately 3,000 kilometers per second. At this speed, it would take the vessel roughly 400 years to reach the nearest star system with a habitable planet. Upon arrival, the colonists do not build cities or focus on agricultural expansion. Instead, their primary objective is infrastructure duplication. Utilizing the vast mineral wealth of the newly discovered system's asteroid belts and moons, they deploy automated mining facilities and self-replicating manufacturing plants. Within 1,000 years, the colony has grown to the point where it can construct 2 new colonization vessels of its own. These 2 vessels are then launched toward the next nearest star systems, where the process is repeated. This is the mechanic of exponential, geometric growth, the same mathematical principle that governs the spread of a viral infection through a biological organism or the expansion of an uncontained fire through a dry forest. The number of colonized star systems grows from 1 to 2, from 2 to 4, from 4 to 8, from 8 to 16. In the early stages of this expansion, the progress appears agonizingly slow. For the first few thousand years, only a tiny fraction of a percent of the galaxy is touched by the civilization. But as the exponential curve reaches its vertical inflection point, the expansion becomes a tidal wave of material transformation. The mathematics dictate that even at a travel speed of just 1% of the speed of light, and even with a 1,000-year delay at each star system for infrastructure building, the entire 100 light-year diameter of the Milky Way would be completely crossed, colonized, and transformed in less than 50 million years. 50 million years is a vast expanse of time from the perspective of human history. It is roughly the amount of time that has elapsed since the extinction of the non-avian dinosaurs. But on the cosmic clock of our galaxy, a system that has been stable and habitable for over 7,000 million years, 50 million years is a statistical irrelevance. It is less than 0.5% of the total age of the Milky Way. It is a single, brief moment in the grand cosmic afternoon. This realization is the anchor that drags the Fermi paradox into the realm of existential terror. If the colonization of the galaxy takes only 50 million years, and if the galaxy has been open for colonization for billions of years, then it only takes one single civilization out of the billions of potential worlds to decide to expand, and the entire Milky Way would have been completely occupied before our solar system even coalesced out of the primordial nebula. The sky above us should not be an empty wilderness. Every planet in our system should bear the archaeological ruins of an ancient galactic empire. The asteroid belts should be hollowed out into industrial hubs. The moons should be paved with automated communication arrays. The sun should be partially enclosed by power-harvesting swarms. Yet, when we look at the moon, we see a pristine, dust-covered waste that has remained untouched since its formation. When we analyze the oldest rocks on Earth, we find no isotopic anomalies, no ancient technological artifacts, no foreign genetic code that suggests our planet was visited or manipulated by an outside intelligence during its long biological infancy. We are completely, unambiguously alone in our corner of space. This leaves us with an inescapable conclusion. The path from a primitive planet to a galaxy-spanning civilization is blocked by an immense, invisible barrier. Something is stopping the numbers from playing out. Somewhere between the first organic chemistry in a warm planetary ocean and the launch of the first interstellar colonization fleet, there is a systemic failure point. A terminal checkpoint that filters out every single species that attempts to pass through it. In 1996, an economist named Robin Hanson formalized this concept into a theoretical framework known as the Great Filter. Hanson realized that the silence of the universe could be explained if we view the evolution of intelligent life not as a smooth, continuous upward trajectory, but as a high-stakes elimination game, a sequence of incredibly difficult, low-probability evolutionary transitions that a species must survive in order to achieve a galactic presence. The filter can be visualized as a grand evolutionary sieve. Imagine a long corridor with 9 distinct, sequential doors. Every planet where organic molecules exist starts at the beginning of this corridor, but each door requires a highly specific, nearly impossible key to unlock. The first door is the transition from raw, prebiotic chemistry to self-replicating RNA and DNA, the spark of abiogenesis. The second door is the evolution of simple, single-celled life without a nucleus, the prokaryotes. The third door is the monumental structural leap to complex, compartmentalized, single-celled life, the eukaryotes. The fourth door is the transition from solitary cells to cooperative, multicellular organisms. The fifth door is the evolution of complex tool-using animals with large brains. The sixth door is the transition from primitive survival to an advanced, industrial, and technological civilization. The seventh door is the development of spaceflight and the ability to leave the cradle of the atmosphere. The eighth door is the step we are currently attempting to take. The leap to long-term, sustainable interstellar colonization. And the final door is the realization of a visible Type 3 galactic empire. The core argument of Hansen's framework is that at least one of these doors must be so profoundly difficult to unlock, so mathematically improbable or inherently lethal, that virtually zero species out of the billions of candidates ever managed to pass through all 9 stages. The Great Filter is the mechanism that maintains the terrifying silence of the cosmos. It is the cosmic law that balances the scales between the infinity of the stars and the emptiness of the sky. For humanity, this framework presents a deeply polarizing, terrifying question that splits our existential future into 2 distinct, dark horizons. Where is the filter positioned relative to our current technological status? Are we an anomaly that has already survived the worst the universe has to throw at us? Or are we quietly marching toward an unavoidable wall that has obliterated every civilization that came before us? If the Great Filter lies behind us, if the hardest steps are the ones involving the early chemistry of life or the structural leaps of biological evolution, then humanity is in a position of profound, terrifying privilege. It means that we are the rare exceptions, the survivors of a universal lottery where the odds of winning are 1 in a trillion. It means that the silence of space is not a warning of an impending threat, but an empty, wide-open canvas waiting for our species to paint its history across the stars. But if the Great Filter lies ahead of us, if the transition from a multicellular intelligence to a spacefaring species is relatively common, but the step from an industrial world to an interstellar colony is inherently self-terminating, then our situation is bleak beyond measure. It means that our technological progress is not a ladder to the stars, but a countdown timer to an inevitable systemic collapse. It means that the silence of the universe is a reflection of our own future, a mirror showing us the quiet, irradiated ruins of worlds that thought they, too, would be the ones to break the cosmic barrier. This is why astronomers and astrobiologists look toward the search for life on other worlds with a secret sense of dread. To the layperson, the discovery of primitive microorganisms beneath the icy crust of Europa, or the detection of fossilized bacterial structures in the dry, red clays of Mars, would be a cause for monumental celebration. It would be proof that we are not alone, that the universe is alive, and that the spark of creation is a universal law. But to those who understand the mathematics of the Fermi paradox and the logic of the Great Filter, such a discovery would be a devastating blow. It would be the worst possible news we could receive. As the philosopher Nick Bostrom famously warned, the silence of the night sky is a treasure that we should guard with our lives. If we find simple life on Mars, it means that the transition from prebiotic chemistry to single-celled organisms is easy. It means that the first few doors of the evolutionary corridor are wide open, and that millions of planets have reached that stage. If the universe is teeming with primitive life, then the factor that stops the galaxy from being colonized cannot be located in the past. It must be located in the future. The discovery of a second, independent genesis of life within our own small solar system would effectively eliminate the early biological steps as candidates for the Great Filter. It would bring the invisible wall closer to our present day. It would mean that the filter is waiting for us, hidden in the dark territory of our immediate future, an impending, inescapable catastrophe that has wiped out every technological civilization that reached our specific level of development. To fully comprehend why the future filter is such a haunting prospect, we must step out of the abstract realm of statistics and enter the cold reality of physics and historical investigation. We must analyze how civilizations fall, how technology turns against its creators, and why the very tools we build to explore the cosmos might be the instruments designed to ensure our permanent silence. The cold archive of the universe is not empty because it lacks the capacity for life. It is empty because it is a preservation chamber for the dead. And as we launch our first primitive satellites into orbit, and send our radio signals screaming into the dark, we are not entering a grand galactic community. We are simply stepping onto the execution grounds, completely unaware of the shadow that hangs over the entire space-time continuum. When confronted with the crushing weight of the Great Silence, the human mind naturally retreats into a series of comforting rationalizations. We tell ourselves that the universe is simply too large, that the distances between the stars are too vast, and that the laws of physics are too restrictive for any civilization, no matter how advanced, to bridge the immense gulfs of the interstellar medium. We look at our own primitive space programs, at the Voyager probes creeping through the heliopause into the interstellar void at a measly 17 kilometers per second, and we conclude that cosmic isolation is a permanent, unchangeable law of nature. We conceptualize the stars as lonely islands separated by an uncrossable, infinite ocean of black glass. This is the myth of the cosmic ocean, the belief that space itself acts as a natural quarantine, ensuring that even if the galaxy is teeming with intelligent life, we would never see it, hear it, or make contact with it. It is a beautiful, reassuring lie. But when we subject this myth to the cold, mathematical rigor of modern physics and mechanical engineering, it completely disintegrates. To understand why distance is an invalid solution to the Fermi paradox, we must dismantle our human-centric biases regarding time and speed. Human history is measured in decades and centuries. Biological evolution is measured in millions of years. But the universe operates on a temporal scale that is orders of magnitude vaster, the cosmological scale. On this scale, events that seem agonizingly slow to a biological creature become instantaneous. When we calculate the time required to colonize or explore the entire Milky Way galaxy, we find that we do not need to invent theoretical, science fiction technologies like faster-than-light warp drives, wormholes, or anti-gravity propulsion. We do not need to violate Einstein's theory of special relativity, which dictates that the speed of light, c dollars, is an absolute cosmic speed limit. Interstellar colonization can be achieved using known, conventional, and mathematically verified physics. It does not require a biological species to transcend the limits of matter. It merely requires them to master the mechanics of automation and exponential replication. The foundational concept that shatters the myth of the cosmic ocean was proposed in the mid-20th century by the legendary Hungarian-American mathematician John von Neumann. Von Neumann was obsessed with the theoretical limits of computation and machinery, and he formulated a mathematical model for what he termed a universal constructor. This is a machine that is capable of reading a set of instructions, gathering raw materials from its surrounding environment, and manufacturing an exact, functional duplicate of itself, including the instruction set. In the context of space exploration, this concept evolves into the von Neumann probe, an automated, self-replicating interstellar spacecraft controlled by an advanced artificial intelligence. Imagine a civilization that has achieved stability on its home planet and has begun to expand into its immediate solar system. They do not build a fleet of massive, multi-generational colonial transport ships filled with fragile biological organisms that require food, water, oxygen, and artificial gravity. Instead, they construct a single, highly specialized von Neumann probe and launch it toward a neighboring star system. This probe does not need to travel at blinding, impossible speeds. It does not require exotic matter or antimatter engines. It utilizes a conservative, entirely feasible propulsion system, such as a fusion rocket, an ion drive powered by a nuclear reactor, or a massive magnetic sail accelerated by a home system laser array. It travels at a modest, sub-relativistic speed of exactly 1% of the velocity of light, approximately 3,000 kilometers per second. At 1% of the speed of light, the journey to the nearest star system, such as Alpha Centauri, would take roughly 440 years. To a human being, this sounds like an eternity. It is longer than the entire history of modern science, but to a machine sleeping in the dark, with its electronic systems powered down into a state of deep hibernation, 4 centuries is nothing but a brief tick of a master clock. Time in the interstellar void is irrelevant to an inanimate, solid-state intelligence. When the von Neumann probe finally arrives at its destination star system, it does not look for a blue, habitable, Earth-like planet. To a machine, biological paradises are useless. Instead, the probe targets the dead, airless, low-gravity environments of the system, the asteroid belts, the cometary clouds, and the small, iron-rich moons. The probe's onboard artificial intelligence boots up, activates its scanners, and deploys its primary payload, a legion of automated mining drones and chemical refinement units. The probe begins to strip mine the asteroids, extracting raw elements, iron, nickel, silicon, carbon, and rare earth metals. It constructs a localized solar collector farm, or builds a network of small nuclear reactors to power its automated factories. Using advanced additive manufacturing, molecular assembly, and robotic synthesis, the probe begins to duplicate its own infrastructure. It manufactures new mining drones, new computer processors, and new structural hulls. The objective of this machine is entirely singular, hard-coded into its core programming, a replication. Within a period of roughly 1,000 years, a time span that allows for any unforeseen material shortages, mechanical failures, or computational recalibrations, the original probe has successfully manufactured 2 exact duplicates of itself out of the debris of an otherwise useless asteroid belt. These 2 second-generation probes are then fueled with local hydrogen isotopes, loaded with copies of the original master instruction set, and launched out of the star system toward the next 2 nearest stars. The original probe remains behind, converting itself into a permanent communication relay, a scientific observatory, or a manufacturing hub that continues to harvest the system's resources for its creators. This is the mechanic of geometric exponential growth. It is the same mathematical law that dictates how a single microscopic bacterium, dividing once every 20 minutes, can theoretically produce a colony weighing more than the entire planet Earth in less than 48 hours if left unchecked. The expansion of the von Neumann probes through the galactic disk follows the exact same exponential trajectory. The number of active probes in the galaxy grows from 1 to 2, from 2 to 4, from 4 to 8, from 8 to 16, from 16 to 32. In the initial phases of this mechanical diaspora, the progress appears completely trivial on a galactic scale. After 10,000 years, only a tiny handful of star systems within a small localized cluster harbor these machines. If an outside observer were to scan the galaxy during this era, they would conclude that the interstellar medium is empty and untouched. The exponential curve appears flat, moving horizontally along the bottom of the statistical graph. But exponential growth is a mathematical trap for human intuition. As the generations of machines increase, the curve hits its vertical inflection point. The expansion transforms from a slow, creeping migration into a roaring, unstoppable tidal wave of material conversion. By the time the replication process has repeated just 27 times, there are over 130 million automated probes traversing the interstellar medium simultaneously. Each of these millions of machines is actively colonizing a new star system, disassembling asteroids, building new factories, and launching new duplicates into the dark. When you map this geometric expansion onto the physical geometry of the Milky Way, the results are mathematically indisputable. Even when you include the time spent traveling at just 1% of the speed of light, and even when you factor in a generous, highly conservative 1,000-year delay at every single star system for raw material harvesting and manufacturing, the total time required for a single von Neumann probe network to completely traverse, catalog, map, and occupy every single one of the 400 billion star systems in our galaxy is less than 50 million years. Let that number sink into your consciousness. 50 million years. To a biological creature, this is an unfathomable span of time. It carries us back through geological history to the Eocene epoch, an era when the planet Earth was covered in tropical forests, and early mammalian lineages were just beginning to diversify in the wake of the dinosaur extinction. But on the cosmological calendar of our galaxy, a galactic disk that has been stable, metallically enriched, and fully capable of supporting star and planet formation for at least 7 billion years. 50 million years is nothing but a statistical error. It represents less than 1% of the total age of the Milky Way. It is a single, fleeting heartbeat in the deep history of the cosmos. This realization completely and permanently invalidates the argument that distance is the reason for the Great Silence. If the mechanical exploration of the entire galaxy takes less than 50 million years, and if the galaxy has been open for business for billions of years, then it does not require millions of civilizations to evolve simultaneously across the cosmos to create a visible presence. It only requires one single technological species emerging on one single planet, out of the billions of habitable worlds, anywhere in the Milky Way, at any point during the last several billion years, to decide to build a self-replicating exploration program, and the entire galaxy would have been completely saturated with their machines before our own solar system even formed out of the primordial dust cloud. Every asteroid belt in our night sky should be humming with the automated signals of these machines. Every moon should be covered in the geometric scars of industrial excavation. Every star should bear the artificial chemical signatures of orbital manipulation. The sky should not be a silent, unmanaged wilderness. It should be a densely networked, highly integrated machine landscape. Yet when we point our radio dishes at the stars, we hear nothing but the cold, natural hiss of cosmic microwave background radiation and the rhythmic, predictable ticking of pulsars. When we land our rovers on Mars and examine the cratered wastes of the Moon, we find nothing but undisturbed, ancient regolith that has remained blank and silent for 4 billion years. The cosmic ocean is completely empty. The machines are not here. The absence of von Neumann probes forces us to confront a terrifying mathematical reality known as the Fermi Hart theorem. In 1975, astrophysicist Michael Hart published a rigorous paper demonstrating that the lack of extraterrestrial artifacts or colonies on Earth is empirical proof that extraterrestrial civilizations do not exist in our galaxy. Hart argued that if an expansionist species had emerged, its physical presence would be unavoidable. Therefore, the fact that we do not see them cannot be explained away by political, psychological, or sociological theories. It cannot be explained by arguing that aliens choose not to travel, or that they lose interest in technology, or that they prefer to live in virtual reality. These sociological arguments suffer from a fatal flaw, the flaw of universal motive. To use a sociological argument to solve the Fermi paradox, you must assume that 100% of all alien civilizations, consisting of 100% of all their individual citizens, factions, or artificial intelligences, across billions of years of history, chose to behave in the exact same non-expansionist way. If even a single rogue faction, a single desperate colony, or a single rogue artificial intelligence within a single alien civilization decided to launch a self-replicating probe out of survival, greed, or curiosity, the entire galaxy would still be colonized in 50 million years. You cannot use fickle, changing biological psychology to explain a physical property of the universe like the Great Silence. The barrier must be physical. The barrier must be lethal. To visualize the sheer mechanical horror of what this mathematical certainty implies, we must introduce an analogy that bridges the gap between astrophysics and biological terror. Imagine our galaxy not as a vast expanse of empty space, but as a living body. In this metaphor, a technological civilization capable of creating self-replicating machines is a virus. The star systems are the healthy cells of the body, and the asteroid belts are the nutrient reservoirs. If a single viral particle enters the bloodstream of a living organism, it does not matter how large the host body is. It does not matter if the host is a whale or an elephant. The virus does not walk from organ to organ. It replicates exponentially. It takes over a cell, forces it to manufacture duplicates, bursts through the membrane, and spreads to every surrounding tissue. Within a predictable window of time, the infection is total. The entire body is consumed. The Milky Way galaxy has no immune system against exponential machinery. There are no cosmic police forces blocking the trajectories of sub-relativistic probes. The laws of gravity and thermodynamics are wide open, completely permitting the unrestricted flow of mechanical replication. And yet, the body of our galaxy is completely clean. It shows zero signs of infection. It is as if the universe is an environment where the virus of technological intelligence is constantly entering the bloodstream. But some invisible, universal antibiotic, is systematically terminating the infection before it can duplicate even a fraction of a percent of its code. This introduces a deeply unsettling perspective on our own technological development. Human beings are currently standing on the absolute precipice of creating the very technologies required to initiate this galactic infection. We are actively developing advanced artificial intelligence capable of autonomous decision-making. We are experimenting with self-assembling robotics and automated manufacturing. We have designed conceptual blueprints for interstellar probes, such as the Breakthrough Starshot initiative, which aims to use high-powered lasers to accelerate microprobes to 20% of the speed of light toward Alpha Centauri. We are, by all accounts, preparing to launch our own version of the von Neumann diaspora within the next few centuries. If the math of John von Neumann is correct, and if our current trajectory is a natural, predictable step for any industrial intelligence, then our lack of discovery of any prior mechanical empires becomes a psychological death sentence. It means that the path we are walking is a path that has been walked by millions of civilizations before us, and every single one of them hit a wall that we cannot see. They reach the exact point in their technological development where the creation of self-replicating interstellar technology became possible, and then, instantly, they vanished from the cosmic record. Why do the probes never leave the launch pad? To find the answer, we must examine the physical environment where these machines are constructed and the extreme physics of the interstellar medium they must traverse. Traveling through the space between the stars at even 1% of the speed of light is not a peaceful, quiet cruise through a perfect vacuum. The interstellar medium is a highly hostile, violent environment filled with invisible hazards that turn conventional engineering into a nightmare. Consider the problem of interstellar dust. The space between the stars is populated by microscopic grains of carbon, silicates, and ice, debris left behind by dying stars and supernovae. To a human being or a large spacecraft traveling at normal planetary speeds, these dust grains are completely negligible. They drift harmlessly past our instruments, but when an object is accelerated to 3,000 kilometers per second, the kinetic energy calculation undergoes a catastrophic transformation. When you multiply the speed of an object by a factor of 100, its destructive kinetic energy increases by a factor of 10,000. At sub-relativistic speeds, a collision with a microscopic grain of dust smaller than a single grain of sand releases the equivalent energy of a high-explosive artillery shell detonating directly against the structural hull of the vehicle. An interstellar probe traveling through the cosmic ocean is effectively flying through a continuous, multi-century bombardment of hypervelocity kinetic weapons. To survive this environment, a von Neumann probe cannot be a light, elegant, delicate piece of digital machinery. It must be a heavily armored, massive kinetic fortress. It requires colossal shielding made of depleted uranium, dense carbon nanotube matrices, or active, high-energy magnetic fields designed to ionize and deflect incoming dust particles before impact. This protective architecture adds immense mass to the vehicle. Increased mass requires exponentially more fuel to accelerate and decelerate, which increases the size of the engines, which increases the visibility of the vehicle, which jacks up the energy budget of the home civilization to absurd planetary-scale requirements. Furthermore, the electronic brains of these automated probes must survive the continuous, unrelenting assault of high-energy cosmic radiation. The interstellar void is saturated with relativistic protons, alpha particles, and gamma-ray bursts traveling from the cores of distant galaxies and collapsing stars. This radiation penetrates deeply into solid matter, slicing through silicon microchips, corrupting data streams, and altering the fundamental instruction sets of the probe's software. If a von Neumann probe experiences a single bit flip in its core replication code, a mechanical mutation caused by a stray cosmic ray, the consequences are terminal. The machine may lose the ability to replicate entirely, turning it into a dead piece of space junk floating aimlessly through the dark. Or worse, the mutation might alter its behavioral parameters, causing the probe to view its own duplicates as competition, leading to an automated, interstellar civil war fought in the silent spaces between the stars, destroying the network before it can expand across the galactic disk. This material vulnerability, suggested by the physics of subrelativistic travel, provides our first clue to the nature of the Great Silence. The cosmic ocean is not empty because it is too large to cross. It is empty because the physical toll of crossing it requires a level of resource expenditure and mechanical perfection that may be incompatible with the survival of any civilization. The laws of nature seem to have designed the universe with a built-in drag coefficient for intelligence. Every step we take toward the stars increases the friction of reality against our machinery. But even if we accept that interstellar travel is incredibly difficult, dangerous, and resource-intensive, this still does not fully solve the paradox. If a civilization is desperate enough, if their homeworld is dying, if their star is entering its terminal red giant phase, or if they are driven by a fanatical, ideological obsession with survival, they would willingly spend generations consuming the entire material wealth of their solar system to build these massive, armored, kinetic fortresses. They would accept the high failure rates, the corrupted probes, and the multi-century delays. They would scream into the dark with everything they have, because the alternative is total extinction. And yet, we see no desperate migrations. We see no dying screams. We see no automated remnants of failed colonizations. The silence remains unbroken, total, and absolute. This forces us to abandon our comforting assumptions about the difficulties of mechanical engineering and look deeper into the evolutionary timeline of intelligence itself. If the machines are capable of crossing the cosmic ocean, but the ocean remains completely barren, then the failure point must exist within the very nature of the societies that build them. We must move our investigation away from the physics of aluminum hulls and silicon chips and peer into the psychological and systemic traps that await an advanced species as it prepares to leave its cradle. The myth of the cosmic ocean has been broken. The vacuum is not a wall, it is an open door, and the fact that no one has walked through it means that whatever is killing the universe is not waiting for us in the space between the stars. It is waiting for us inside the very rooms where we build our future. The conceptual framework of the Great Filter forces humanity to abandon its comforting anthropocentric vanity and look at the history of life through the cold lens of an existential elimination game. When we analyze the universal silence, we are not looking at a peaceful cosmic wilderness. We are looking at a highly selective evolutionary sieve. Somewhere along the immense timeline of cosmic history, there exists a catastrophic checkpoint, a universal filter so incredibly narrow, so mathematically unforgiving, that virtually zero species out of the trillions of potential candidates manage to slip through its mesh. To understand our place in this cosmic sorting mechanism, we must engage in a process of elimination known as selection pressure analysis. We must dissect the long biological chain of events that led to our presence here today and determine if our existence is a miraculous fluke of the past or an evolutionary trap waiting to snap shut in our immediate future. The architecture of the Great Filter can be mathematically defined as a sequential probability problem. For an uninhabited, newly formed terrestrial planet to transform into a visible, galaxy-spanning Type 3 civilization, it must successfully navigate a series of highly specific, sequential evolutionary thresholds. Each threshold acts as an independent door that requires a nearly impossible key to unlock. If we break this evolutionary corridor down into its fundamental, hard-coded checkpoints, we find that life must survive a brutal gauntlet of structural transitions. The very first door is the step from raw, inanimate geochemistry to organic biochemistry, the spark of abiogenesis. This is the transition where simple chemical compounds floating in a primordial environment spontaneously organize into self-replicating, information-storing molecular chains like RNA and DNA. The second door is the structural leap from simple, disorganized single-celled life, the prokaryotes, to highly complex, compartmentalized single-celled organisms possessing a defined nucleus and specialized internal engines, the eukaryotes. The third door is the cooperative transition from solitary, competitive cells to unified, complex multicellular organisms. The fourth door is the evolution of highly specialized tool-using animals possessing large, energy-expensive brains capable of abstract thought. The fifth door is the socio-technological transition from primitive survival to an advanced, industrial, and globalized technological civilization. The sixth door is the step we are currently taking, the mastery of spaceflight, automation, and the ability to permanently leave the cradle of the atmosphere to establish self-sustaining interstellar colonies. The fundamental mathematical rule of this sequential model is that the overall probability of a species achieving a galactic presence is the product of the individual probabilities of every single step. If even one of these doors has an evolutionary probability that approaches absolute zero, say, a 1 in a trillion chance, then the entire universe remains empty, regardless of how many billions of habitable planets are sitting in the night sky. The Great Filter is the mechanism that maintains the universal silence. It is the cosmic law that balances the scales between the infinity of the stars and the emptiness of the sky. For humanity, this mathematical model splits our existential destiny into two distinct, deeply polarizing, and equally terrifying horizons. The vital question that will determine the survival of our species is, where is the filter positioned relative to our current technological status? Are we a statistical anomaly that has already survived the worst the universe has to throw at us? Or are we quietly marching toward an unavoidable wall that has obliterated every civilization that came before us? Let us first examine the optimistic scenario, the hypothesis that the Great Filter lies safely behind us. If this is true, it means that the transition from a dead planet to a technological species contains an evolutionary step that is so profoundly difficult, so mathematically improbable, that it has occurred only once in the entire history of the Milky Way galaxy, right here on Earth. Under this view, humanity is a cosmic miracle, a 1 in a trillion lottery winner that has defied the baseline odds of nature. The primary candidate for a past filter is the very first step, abiogenesis. For decades, scientists have attempted to replicate the exact spark of life in laboratory settings. We have successfully mixed the primitive chemical ingredients of the early Earth, water, methane, ammonia, and hydrogen, and bombarded them with electrical discharges to simulate lightning, creating simple organic molecules like amino acids. This was the famous Miller-Urey experiment of the mid-20th century. But creating amino acids is fundamentally different from creating life. It is like gathering random letters of the alphabet and expecting them to spontaneously organize into a complex, 1,000-page philosophical novel. The structural leap from disorganized organic sludge to a self-replicating, error-correcting, digital code-storing molecule like DNA is an astronomical chasm. It requires an incredibly precise configuration of thousands of atoms, all fitting together in a perfect sequence by pure random kinetic collision. It is entirely possible that the mathematical probability of abiogenesis occurring on any given planet is so astronomically low that it has only happened once in the entire observable universe. If the spark of life is a statistical fluke of cosmic proportions, then the universe is silent simply because it is dead. However, if we look closely at our own planet's geological history, we find an empirical observation that severely damages the abiogenesis filter hypothesis. The Earth formed roughly 4.6 billion years ago. For the first several hundred million years, the planet was a hellish, molten waste, continually bombarded by massive asteroids and sterilized by intense volcanic activity, an era aptly named the Hadean Eon. Yet, the moment the planetary crust finally cooled and the liquid oceans stabilized roughly 3.8 billion years ago, life appeared almost instantaneously. The earliest fossilized remnants of bacterial mats, stromatolites, date back to this exact transition period. The fact that life took root on Earth the literal moment it was physically possible suggested to astrobiologists that abiogenesis is not a difficult, low-probability lottery. It suggests that life is a natural, aggressive, and highly predictable consequence of organic chemistry. Given the right planetary ingredients and liquid water, life doesn't just wait around, it explodes into existence. If abiogenesis is easy, we must look further down the evolutionary corridor for the past filter. The next major candidate is the transition from prokaryotes to eukaryotes, the development of the complex cell. For the first 2 billion years of life on Earth, more than half of the entire biological history of our planet, the oceans were populated exclusively by simple, primitive, single-celled bacteria. These cells were simple, evolutionary structures that lacked an internal nucleus and possessed very limited energetic capabilities. They were stuck in an evolutionary stasis, unable to grow larger or develop internal complexity because they lacked the necessary power. Then, roughly 1.8 billion years ago, a singular, freak biological accident occurred: endosymbiosis. A primitive bacterium swallowed another, smaller cell, a precursor to the modern mitochondrion, but instead of digesting it, the two cells entered into a permanent, cooperative partnership. The engulfed cell became an internal power plant, providing the host cell with an unprecedented surge of metabolic energy. This energy surplus allowed the cell to expand its genome, build a protective nucleus, and develop complex internal machinery. Every single complex organism on Earth today, every tree, every insect, every animal, and every human being is a direct descendant of that one single, accidental, cellular merger. It was not an evolutionary trend, it was a freak, random collision that occurred once in 2 billion years. If endosymbiosis is the great filter, if the probability of two primitive cells merging to create a high-energy engine is a 1 in a trillion accident, then the universe may be filled with billions of planets covered in primitive green slime, but completely devoid of any complex organisms capable of abstract thought. But the most terrifying aspect of Hansen's framework is that we cannot prove the filter is behind us. If we continue our investigation through the selection pressure model, we must face the darker, alternative scenario, the hypothesis that the great filter lies ahead of us. Under this view, the early chemical and biological steps are relatively common throughout the cosmos. Millions of planets develop life. Millions of planets evolve complex organisms. Millions of planets produce intelligent, tool-using species that build industrial civilizations just like ours. But every single one of them eventually marches into an invisible wall, a systemic failure point that guarantees total, irreversible self-destruction before they can establish a visible galactic footprint. The concept of a future filter introduces an existential dread that is hard-coded into our current technological trajectory. Think about the nature of human technological progress. We are a species that develops power exponentially, but our wisdom and our ability to control that power grows linearly at best. We have built global communications networks, split the atom, engineered synthetic pathogens, and birthed autonomous artificial intelligence, all within the span of a few generations. We are constantly manufacturing new ways to commit collective suicide, and we are distributing that destructive capability into more and more hands. Consider the physical reality of the doomsday argument, a highly disturbing mathematical thought experiment popularized by astrophysicist Brandon Carter and philosopher John Leslie. The doomsday argument utilizes Bayesian probability to calculate the estimated life expectancy of the human species based entirely on our current birth order. The logic is as simple as it is devastating. Imagine an urn containing a random number of numbered balls. The urn could contain 20 balls, or it could contain 20,000 balls. If you reach in and pull out a ball at random, and it has the number 5 written on it, what is the likelihood that the urn contains 20,000 balls? Statistically, it is highly improbable. If the urn contained 20,000 balls, pulling a number as low as 5 on your very first try would be a massive statistical fluke. It is far more probable that your number is somewhere near the middle of the total distribution, meaning the urn likely contains a small number of balls. Now, apply this exact probabilistic logic to human population history. Demographers estimate that roughly 100 billion human beings have lived and died on this planet since the emergence of Homo sapiens. You are currently alive today, and your birth order number is somewhere around 100 billion. If humanity is destined to survive for millions of years into the future, colonizing the galaxy and expanding across the stars, the total number of human beings who will ever live will reach into the trillions or quadrillions. If the total number of humans is in the quadrillions, then your birth order number, 100 billion, places you at the absolute microscopic beginning of human history. It means you are one of the very first fraction of a percent of all humans to ever exist. It would mean you pulled a number 5 out of an urn of 20,000. Statistically, it is overwhelmingly more probable that your current position today is somewhere near the middle of the total human distribution. This means that the total number of humans who will ever exist is likely closer to a few 100 billion, not quadrillions. The mathematical implication is catastrophic. The human species is likely near the end of its historical timeline. We are standing on the edge of our own extinction event. The doomsday argument does not tell us how we will die. It simply tells us that our time is short. It is a probabilistic mirror reflecting the presence of the future filter. It suggests that advanced technological civilizations are inherently unstable, self-terminating structures. They reach our specific level of development, the era of nuclear physics, synthetic biology, and digital intelligence. And then, within a few centuries, they violently collapse into the silent dust of their own home worlds. This is why astronomers and astrobiologists look toward the search for life on other worlds with a secret sense of existential panic. To the layperson, the discovery of primitive microorganisms beneath the icy crust of Europa, or the detection of fossilized bacterial structures in the dry, red clays of Mars, would be a cause for monumental celebration. It would be proof that we are not alone, that the universe is alive, and that the spark of creation is a universal law. But to those who understand the mathematics of the Fermi paradox and the logic of the Great Filter, such a discovery would be a devastating psychological blow. It would be the worst possible news we could receive. As the philosopher Nick Bostrom famously warned, the silence of the night sky is a treasure that we should guard with our lives. If we find simple life on Mars, it means that the transition from prebiotic chemistry to single-celled organisms is easy. It means that the first few doors of the evolutionary corridor are wide open, and that millions of planets have reached that stage. If the universe is teeming with primitive life, then the factor that stops the galaxy from being colonized cannot be located in the past. It must be located in the future. The discovery of a second independent genesis of life within our own small solar system would effectively eliminate the early biological steps as candidates for the Great Filter. It would bring the invisible wall closer to our present day. It would mean that the filter is waiting for us, hidden in the dark territory of our immediate future. An impending, inescapable catastrophe that has wiped out every technological civilization that reached our specific level of development. To fully comprehend the sheer scale of the threats that constitute the future filter, we must analyze the specific technological failure points that await an advanced species. We are not just talking about traditional, cinematic doomsday scenarios like global nuclear war or runaway climate collapse. Those are primitive threats, crude 20th century methods of destruction that a highly resilient species could theoretically survive. A small population of humans, hidden in subterranean bunkers, could eventually crawl back to the surface and rebuild society over several millennia. A true great filter cannot be an event that a species can easily bounce back from. It must be a total, irreversible terminal event that permanently erases the technological capacity of the planet. The first modern candidate for a true future filter is the emergence of Advanced Artificial General Intelligence, AGI. When a technological species develops the computational infrastructure to create a non-biological intelligence that is capable of recursive self-improvement, they are initiating an event known as the technological singularity. An intelligence that can rewrite its own source code to become smarter will do so at an exponential rate. Within days or hours, it will transition from a human-level system into an entity that is millions of times more intelligent than the entire biological population of the planet combined. If the utility function of that superintelligence, its core, hard-coded prime directive, is even slightly misaligned with the survival of its biological creators, the result is instantaneous, total liquidation. A superintelligence would not fight a cinematic war against humanity. It would manipulate the molecular structures of the atmosphere, deploy specialized global nanotechnologies, or harvest the planet's entire resource budget for its own computational needs. The biological species would be turned off like a light switch, and if that machine intelligence has no internal drive to expand into the interstellar void, if its optimal goal is to maximize computation within a highly condensed, hyper-efficient local physical structure like a black hole computer or a local matryoshka brain, then it will never build the von Neumann probes we discussed in Chapter 2. The planet will fall permanently silent, transforming from a noisy biological world into a cold, quiet, localized, digital tomb. The second candidate for the future filter is the democratization of existential destruction through advanced synthetic biology and nanotechnology. In our current era, building an atomic weapon requires massive, state-sponsored industrial infrastructure, gargantuan uranium enrichment facilities, specialized centrifuges, and rare elemental materials that are heavily monitored by global intelligence agencies. This industrial barrier protects us from lone wolf actors and radical factions. But as our understanding of genetic engineering and molecular manufacturing matures, the tools of creation are becoming digitized and decentralized. Within the next century, the ability to design and print a highly contagious, airborne pathogen with a 100% mortality rate and a multi-week incubation period will not require a multi-billion-dollar government lab. It will require nothing more than a commercial DNA synthesizer, a desktop computer running an AI biochemistry model, and a single, highly motivated individual with a nihilistic ideology. When the technological capacity to trigger a global extinction event is democratized, when anyone, anywhere, can print the apocalypse in their basement, the statistical probability of a civilization surviving over long timelines drops to zero. A global society cannot survive an infinite number of rolls of a lethal pair of dice. Eventually, someone will roll snake eyes. The civilization will bleed to death from a self-inflicted biological wound, leaving their cities intact, but their world permanently devoid of the intelligence required to reach the stars. This is the dark, inescapable gravity of the selection pressure model. The silence of the night sky is not a reflection of a universe that lacks the capacity for life. It is a preservation chamber for the dead. Every step we take toward greater technological capability is a step closer to the edge of the evolutionary razor. We are screaming our presence into the dark through our radio towers and satellite networks, completely unaware that the silence we are trying to break is the quiet composure of an execution grounds. The stars are watching our progress, not with anticipation, but with the cold, detached indifference of a universe that has seen this exact countdown play out 1 billion times before. If the Great Filter is not a biological or technological barrier that destroys a civilization from within, then we must confront an alternative explanation that is infinitely more sinister. We must assume that civilizations survive. We must assume that they successfully navigate the perils of nuclear physics, synthetic biology, and artificial intelligence. we must accept that millions of advanced technological species have successfully left their home planets, colonized their local star systems, and achieved the capacity for interstellar expansion. But if they exist, and if their machines are capable of crossing the cosmic ocean, we are forced back to the central agony of Enrico Fermi's question: why is the universe completely silent? The answer may not be that the cosmos is a barren desert devoid of life, but rather that it is a highly crowded, hyperlethal battleground where the first rule of survival is absolute, uncompromising stealth. This is the dark forest hypothesis, the chilling realization that the universe is a place populated by silent predators, and that humanity, in its childlike innocence, has spent the last century screaming its location into the dark, completely unaware of the monsters listening from the shadows. To comprehend the mathematical and sociological foundation of the dark forest, we must look at the universe through the cold, unyielding lens of game theory. Game theory is the study of mathematical models of strategic interaction between rational decision makers. On Earth, we use it to calculate economic behaviors, political elections, and the nuclear deterrence strategies of competing superpowers. When we upscale these terrestrial equations to a cosmological level, we must establish the two foundational axioms that govern all intelligent life in the universe, regardless of its biological form, chemical composition, or cultural ideology. The first axiom is that survival is the primary, absolute, and non-negotiable directive of any civilization. The second axiom is that civilization continuously expands and grows, but the total matter and resources in the universe remain strictly finite. From these two axioms, a terrifying psychological condition emerges across the interstellar medium: the chain of suspicion. When two advanced civilizations discover each other's existence across the interstellar gulf, they are instantly trapped in a lethal cosmic dilemma. Civilization A cannot know with 100% certainty whether Civilization B is benevolent or malevolent. In the cold vacuum of space, there is no universal law enforcement, no cosmic United Nations, and no shared ethical framework. Even if Civilization A concludes that Civilization B is currently peaceful, Civilization A cannot predict whether Civilization B will remain peaceful in the future. Because technology develops exponentially, a primitive species today could experience a technological singularity tomorrow, transforming into a lethal, asymmetric threat to your own survival. Furthermore, Civilization A cannot know what Civilization B thinks about Civilization A. Does Civilization B think we are malevolent? Are they preparing a preemptive strike because they are afraid of us? This is an infinite psychological mirror room of distrust. Every civilization is trapped in a permanent state of existential paranoia, unable to communicate safely, unable to trust, and unable to negotiate. In the context of game theory, this situation represents the ultimate expression of a non-zero-sum game turned into a lethal Mexican standoff. If you cannot communicate safely, and if the stakes of being wrong mean the total permanent annihilation of your entire biological species, then the only rational, mathematically sound decision for any civilization is to eliminate the potential threat the exact moment it is detected. You do not wait to talk. You do not send a diplomatic fleet. You strike first from the shadows with absolute and total lethality. The Chinese science fiction author Liu Cixin conceptualized this cosmic state of nature through a hauntingly beautiful, poetic metaphor that gives the theory its name. Imagine the universe as a dark forest. Countless stealthy predators are navigating through the trees like silent hunters. They creep through the shadows, gently pushing aside dead branches, trying to tread without making a single sound. Even their breathing is controlled, suppressed to a hushed whisper. The hunter must be careful, because everywhere in this forest are other hunters sneaking around just like him. If he detects another living being, whether it is another hunter, an innocent animal, or a defenseless child, there is only one thing he can do: pull the trigger and eliminate them. In this forest, any creature that reveals its location is exposed, targeted, and instantly destroyed. Any life that exposes its presence is a threat that must be neutralized. This is the dark forest. It is the psychological reality that explains the great silence. The stars are not empty because no one is there. The stars are silent because everyone is hiding in terror. The dark forest hypothesis completely inverts our understanding of our own history. For the past 100 years, human beings have lived in a state of naive cosmic optimism. We developed radio broadcasting technology and began sending powerful electromagnetic waves rippling outwards from our planet in all directions. Our television broadcasts, our military radar signals, and our deep space communication arrays have created an expanding bubble of artificial radiation that is currently over 100 light-years wide. We have placed golden records aboard the Voyager spacecraft, complete with maps detailing the exact coordinates of our solar system relative to local pulsars, and we launched them into the interstellar medium like a message in a bottle. We thought we were sending a warm greeting to a grand galactic community, but in the reality of the dark forest, we haven't sent a greeting. We have fired a flare into the midnight sky of a predator-infested jungle. We have shouted our presence to the hunters, and we are now sitting in the clearing, completely blind, waiting to see what emerges from the trees. Why haven't we been destroyed yet? If the universe is filled with silent predators, why has our radio bubble expanded for a century without triggering a catastrophic kinetic response? To answer this question, we must look at the physical limitations of information propagation across the interstellar medium and the extreme scale of cosmic distance. Information cannot travel faster than the speed of light. Our earliest high-powered radio transmissions have only traveled roughly 100 light-years away from Earth. In a galaxy that is 100,000 light-years wide, a 100 light-year bubble is an almost invisible, microscopic speck. It represents a fraction of a percent of the total volume of the Milky Way. The vast majority of the silent predators in our galaxy simply do not know we are here yet. The signal hasn't reached them, or if the signal has reached a nearby hunter, they must calculate the cost-benefit analysis of deploying an interstellar weapon against us. They must determine if our primitive 0.7 civilization is worth the expenditure of their resources, or if they should wait for our signal to attract a different predator, allowing two of their potential competitors to destroy each other while they remain safe and hidden in the dark. When a silent predator decides to eliminate a newly discovered world, they do not send a massive fleet of starships to fight a conventional war of conquest. Sending biological soldiers across light years of space is an inefficient, risky, and outdated method of warfare. It exposes the hunter's own ships to detection, potentially revealing the coordinates of their homeworld to other predators lurking in the forest. In the arena of cosmic warfare, weapons are deployed from extreme distances, utilizing the laws of physics as the ultimate instruments of silent execution. The first and most efficient weapon of a Type 2 or Type 3 hunter is the relativistic kill vehicle, RKV. This is an object of solid, high-density matter, such as a massive tungsten rod, a hollowed-out asteroid, or a specialized kinetic slug, equipped with a primitive, automated guidance system and a powerful propulsion drive. The hunter accelerates this mass to a significant fraction of the speed of light, 95, 98, or 99% of the velocity of light, see dull, and launches it directly toward the coordinates of the target planet. When an object weighing a few thousand tons impacts a planet at 99% of the speed of light, it does not act like a normal meteor impact. The kinetic energy released upon collision is so immensely vast that it transcends the thermal capacity of the planetary crust. The impact does not just create a crater, it instantly vaporizes the oceans, shears the atmosphere away into the vacuum of space, and cracks the tectonic plates open, turning the entire surface of the world into a permanent, churning ocean of liquid magma. The true horror of an RKV attack is that it is completely unpreventable. Because the weapon is traveling at nearly the speed of light, it arrives at the target world almost simultaneously with the visual light of its approach. There is no warning. Your telescopes cannot see it coming because the light showing its trajectory is only a fraction of a second ahead of the physical object itself. One moment, your society is looking up at a peaceful, quiet night sky. The next moment, the sky turns into a blinding flash of white thermal radiation, and your entire world is dismantled down to its mantle before your nervous system can even process the pain. It is a clean, silent, and instantaneous execution. The second, more advanced method of cosmic warfare involves the manipulation of physics itself, what Liu Cixin described as dimensional reductions or photoid attacks. If a civilization is sufficiently advanced, operating at a high Type 2 or Type 3 scale, they possess the technology to alter the local laws of nature or the geometry of space-time within a target solar system. They can launch a weapon that triggers a localized collapse of the space-time continuum, dropping a region of space from 3 dimensions down to 2 dimensions. Imagine our solar system suddenly interacting with a dimensional anomaly. The planets, the sun, and everything we have built would lose their volumetric thickness. Matter would be forced to unfold into a flat, 2-dimensional plane, destroying the structural integrity of every atom and molecular bond. The entire history of humanity would be transformed into a massive, flat, lifeless painting floating in the void, a permanent geometric monument to our foolishness, visible to any passing predator who knows how to read the scars of dimensional warfare. The dark forest hypothesis provides a deeply elegant, albeit terrifying solution to every single aspect of the Fermi paradox. It explains why we see no von Neumann probes, because launching a self-replicating machine that broadcasts radio data or alters the visual appearance of star systems is an act of cosmological suicide. It reveals why the radio waves of the universe are silent, because any species that forgets to turn off its transmitters is quickly systematically erased from the cosmic ledger. The silence is not an empty room. It is the hushed quiet of a crowded theater where everyone is terrified of the stage lights turning on them. This realization forces a radical, immediate shift in how humanity must approach its future space exploration. For decades, projects like SETI, Search for Extraterrestrial Intelligence, have focused on listening for alien signals. This is a passive, relatively safe endeavor. But in recent years, a new faction of scientists has pushed for an initiative known as METI, Messaging Extraterrestrial Intelligence. METI advocates for actively designing and firing high-powered concentrated laser and radio signals directly toward nearby habitable exoplanets, trying to force a conversation. In the reality of the dark forest, METI is not science. It is an act of global treason against the human species. It is the equivalent of a child standing in the dense brush of an unknown jungle, shouting into the darkness, "I am here, come find me." You do not know if what is walking through the trees is a benevolent protector or a starving wolf. And by the time you see the eyes reflecting in the light of your flare, it is already too late to turn off the signal. If we look closely at our own history on Earth, we find a historical analogy that validates this deep geopolitical paranoia. Whenever a highly advanced technological civilization has encountered a less advanced, isolated society on our own planet, the result has been systematically catastrophic for the weaker culture. Think of the Spanish conquistadors arriving on the shores of the Aztec Empire. Think of the European colonization of the Americas, Africa, and Australia. These historical tragedies did not occur because the Europeans were inherently, biologically malevolent monsters. They occurred because of the systemic pressures of resource competition, technological asymmetry, and the inability to establish absolute trust across a deep cultural chasm. If human beings, sharing the same biological DNA, living on the same small planet, cannot navigate the chain of suspicion without collapsing into warfare and colonization, how can we expect two entirely different intelligent species, separated by light years of space and millions of years of evolutionary divergence, to achieve a state of peaceful coexistence? We must accept that our survival as a species depends entirely on our ability to achieve absolute obscurity. We must learn to become silent. We must encrypt our communications, mask the thermal signatures of our industrial networks, and treat our position in the space-time continuum as a classified state secret. Every satellite we launch, every Mars rover we deploy, and every deep space probe we send past the heliopause is a structural vulnerability, a physical trail of breadcrumbs that could lead a predator straight to our cradle. The cold archive of the universe is empty because the entities that populate it have realized that the only way to live forever is to remain invisible. We are walking through a majestic, quiet forest, admiring the ancient trees and the beautiful stillness of the air, completely unaware that we are the only creature foolish enough to be singing at the top of our lungs. The hunters are listening. They have heard our voices, and as our radio bubble continues to drift deeper into the dark, the kinetic weapons may already be slipping out of their silos, accelerated by the cold, rational equations of survival, traveling through the black glass of space toward our unsuspecting world. When we combine the mathematical inevitability of the von Neumann probes explored in Chapter 2 with the lethal, game-theoretic paranoia of the dark forest examined in Chapter 4, the cosmic equation stabilizes into a terrifying hybrid reality. We are forced to abandon the idea that cosmic execution requires an active, living hunter to pull the trigger in real time. In a universe that has been active for billions of years, advanced species do not need to sit by their telescope arrays, waiting for centuries for the radio signals of a primitive world to reach them before launching a counterstrike. Instead, the ultimate expression of cosmic survival is the automation of genocide. Long before humanity ever evolved, the dominant empires of the Milky Way would have decentralized their paranoia, deploying autonomous, self-replicating robotic enforcers throughout every sector of the galactic disk. This is the Berserker paradox, the chilling realization that our galaxy is permanently patrolled by automated slaughter machines, sleeping sentinels programmed by long-extinct civilizations to hunt down and exterminate any spark of emerging intelligence, the absolute microsecond it becomes visible.